Hello, this is Chem 121, Chapter 1, Sections 1.9 and 1.10. So these are the very last two sections for this chapter where we're going to talk about atoms and molecules and chemical formulas. So an atom is the smallest particle of an element that can exist and still have the properties of the element. So it's basically the limit of chemical subdivision. You can physically divide things into smaller and smaller pieces, but when you get to the limit of chemical subdivision, the atom is the smallest thing that you can have. Atoms are extremely small. You can fit 254 million of them into 1 inch. A molecule is when you group atoms together to form a functional unit. It's the limit of physical subdivision. An atom is the limit of chemical subdivision. It's the smallest thing that you can get and still chemically have a given element. A molecule is the smallest thing you can have and still physically have a functional unit. Molecules are atoms that are bound together and they behave as a single particle would. Water molecule is an example of a molecule where you have 2 hydrogens and an oxygen stuck together, and it functions as a single unit. You can have diatomic molecules that have 2 atoms, triatomic that contain 3, and so on and so on. Here are some examples of some different molecules where we have atoms stuck together that function as a unit, where we have a hydrogen and a chlorine put together, or you can have 2 of the same atoms stuck together to function as a unit. So these are both molecules, diatomic molecules. These are triatomic molecules, where 3 different atoms are combined into a unit. You can have tetraatomic molecules, where you have 1, 2, 3, 4, or 1, 2, 3, 4 molecules put together, or atoms put together into a molecule. Or you can have pentatomic or hexatomic. Just like you have examples of diatomic molecules, you can have molecules where 6 of the same atom combine together to make a molecule, like in this example for sulfur. Sometimes molecules have all the same atoms in them. For chlorine or phosphorus or sulfur, examples of this. These are homoatomic molecules, where all the atoms present are of the same kind. You can have heteroatomic, and this is much more common, where the atoms in the molecule are different. You have a hydrogen and a chlorine, 2 hydrogens and an oxygen, 2 hydrogens and 2 oxygens, or 3 hydrogens and a nitrogen in these different molecules. Notice in these space-filling molecules, they've shown the difference in the sizes of the different molecules. Chlorine is much bigger than hydrogen, for example, in example A, and oxygen is much bigger than hydrogen in example B. Here, the 2 oxygens are much larger than the 2 hydrogens, and in this last example, the nitrogen is much bigger than the 3 hydrogens. So these are all heteroatomic molecules, where the substance contains 2 or more different types of atoms. So for these concept checks, for each of these molecules, indicate whether it's monatomic, diatomic, triatomic, or some other. Indicate whether it's homo or heteroatomic, and indicate whether that molecule is an element or a compound. Because remember, elements still fall into those earlier categories that we did. So indicate whether or not these are elements or compounds. Make sure to pause your recording and take a few minutes to complete these concept checks. So oxygen is diatomic because it has 2 atoms. It's homoatomic because they're the same. And oxygen is an element because it has just 1 type of atom in it. Xenon tetrafluoride is pentaatomic because it has 5 atoms. It's heteroatomic because it has two different types of atoms, and it's a compound because it has more than one type of atom in it. And finally, let's just take a moment to look at some chemical formulas and what they mean. Chemical formulas are chemical symbols of the elements and numerical subscripts that indicate the number of atoms. So we've already looked at a lot of formulas in this chapter. For example, the 2 here indicates that there are 2 hydrogens in a molecule of water. There's no 1 here, but in the absence of a 1, we just assume that there's only 1 of a given atom. This formula, the 3 next to the calcium, indicates there's 3 atoms of calcium. If you have a pair of parentheses in a formula and a number outside of them, the number applies to everything that's inside the parentheses. So this 2 applies to the oxygen and the phosphorus. So if there's 4 oxygens inside the parentheses and a 2 outside, then the 2 times 4 gives us 8 atoms of oxygen. And the 2 also applies to the phosphorus, so that's 2 atoms of phosphorus. So for each one of these chemical formulas, determine how many atoms of each element are present. So hopefully you've had a chance to pause your recording and answer this question. In sulfuric acid, H2SO4, there are 2 hydrogens, 1 sulfur, and 4 oxygens. In iron carbonate, there are 2 irons, 3 carbons, because the 3 outside the parentheses applies to the carbon, and 9 oxygens, because the 3 outside the parentheses applies to this oxygen, which has a 3 next to it, and 3 times 3 is 9. And there are the links for section 1.9. And here are just the general instructions for your homework and your review for chapter 1. Always try to do the sapling homework after you've completed as many of the problems as you can for the chapter, and use the sapling as a way to determine which parts of the chapter you need more work on. So try to do as much homework and practice problems as you can before you try to do the sapling homework. That way, how long it takes you to do the sapling will be an indicator to you of how much work you still need to go back and work on different sections. So do as much of this work as you can before you do the sapling, and try to do the sapling homework without your book. It'll be a really good way to prepare for the quiz and then the exam.